In question 2a, we need to state in words how the force acting on a body is related to the change in momentum of the body. Well, force equals rate of change of momentum. In B, we have a football of mass 0.42 kilograms moving horizontally at 10 meters per second towards the footballer's boot. The ball is then kicked, and we have a graph of force against time, showing how the force between the boot and the ball varies with time as they're in contact. In part 1, we need to state the significance of the area enclosed by the line and the time axis. Well, the area under the graph gives the impulse, or change in momentum, of the body. In part 2, we need to estimate the impulse that acts on the ball, stating an appropriate unit. Well, there are around 22 complete squares under the graph, each of area 20 newtons by 25 milliseconds, giving 0.5 newton seconds per square. This gives an impulse of 22 times 0.5 newton seconds, which is 11 newton seconds. In part 3, we need to find the speed of the ball after it has been kicked, assuming it returns along the same horizontal line it followed when approaching the boot. Well, impulse equals change in momentum, and so 11 newton seconds is the change in momentum, which is the mass times the final speed minus the mass times the initial speed, not forgetting that momentum is a vector, so we must take one direction as positive. So the final speed v is equal to the change in momentum over the mass plus the initial speed. Taking the initial direction as negative, this gives a final speed of 16 meters per second. In C, we need to discuss the consequences if the ball had approached the boot at a higher speed but still received the same impulse. Well, if the ball had approached at a higher speed, the same impulse would lead to the same change in momentum. The initial momentum would have been greater, so as the final momentum is in the opposite direction, it must be lower. Therefore, the final speed of the ball would be lower.